Hello, 6th grade Math Blast 9. Rational numbers on the coordinate plane. Write the ordered pair for each point. When we're doing an ordered pair, the first thing we need to look for is the x-axis. So this is the x. It's the one that goes horizontal. So it's how far over. To the right is positive, to the left is negative. So let's do point A. We go 1, 2, 3, 4, 5. So the x value is 5 to the right, so it's positive. And then we have the y value. The y value is up or down. So it's the vertical axis. Up is positive, down is negative from the origin. That's 0, 0, that point right there. So we were right here. 1, 2, 3, 4, 5, 6. So we went 6 above the x-axis, so that's 6. So A is 5, 6. So now let's do B. The first thing I do is the x. It's moving to the left, so I know immediately that's going to be a negative. It's going to be 1, 2, 3 to the left, so that's negative 3. I'm not moving up or down from the x-axis, so the y value is 0. C. First value I look for is the x. I'm moving to the right, so that's positive. 1, 2, 3, 4, 5, 6. To the right, so I'm right here, and then 1, 2, 3, 4, 5, 6, 7, 8, 9 down from the x-axis. So that's negative 9. Properties and expressions. Write an expression equivalent to 6 parenthesis 3x plus 2y parenthesis. So equivalent means equal to, so it has the same value. So the easiest thing to do here is just distribute the 6. Now when I distribute, I'm going to rewrite this expression. When I'm distributing, I need to distribute to both terms. So 6 multiplied by 3x and 6 multiplied by positive 2y. Well, 6 multiplied by 3 is 18, so it would be 18 x's. And then 6 multiplied by 2y is 12y, positive 12y. So an equivalent expression is 18x plus 12y. There are other expressions that are equivalent. This is just an easy one to find. Tell which given value, if any, is a solution of the equation. So solution means an answer. So we have 15 equals c plus 4 and 50 hundredths, or 4 and 5 tenths, because I can kind of ignore that 0 there. Well, they are adding 4 and 50 hundredths, so I'm going to do the inverse. I need to get this c all by itself. So I'm going to subtract 4 and 50 hundredths. Now this equal sign means these two sides are balanced. So as soon as I took 4 and 50 hundredths away from here, I need to immediately do the same thing here to keep it balanced. So minus 4 and 50 hundredths. So I'm going to do that over here. So 15. Now, when I'm subtracting or adding, I have to line up decimal points. So with 15, there's an invisible decimal point right here to the right. So 4 and 50 hundredths, 4 and 50 hundredths, and I'm subtracting. And now I'm going to put zeros here to make this a little easier. And now 0 minus 0 is 0. 0 minus 5, I need to do some regrouping. So I'm going to take 1 from there, turn it in for 10. 10 minus 5, decimal point comes straight down. 4 minus 4 is 0, and 1 comes straight down. So 10 and 50 hundredths. So now I look to see, is that one of my solutions? Yes, it's right here. So I'm going to circle that. So 10 and 50 hundredths is a solution. Graphing inequalities. Zoe started a graph to show the inequality x is greater than 15. Finish labeling the number line and draw the graph. Well, when I'm labeling a number line, I'm going to put the number right in the middle just to make it easier. And now I just need to finish labeling this one. So 16, 17, 18, 19, 20. Before 15 is 14, 13, 12, 11, and 10. If I was creating my own number line, I would just put 15 and go 1 below and 1 above. But since they had all these little tick mark, little dashes for me, I just filled them out. So now we need to graph x is greater than 15. So the first thing I do is I place a circle at 15. Now, I have to determine whether that circle is going to be open or closed. What tells me that is, can the answer be 15? Well, if x is greater than 15, it cannot be 15. So I'm going to leave it open, okay? So now there's two ways to determine which direction the arrow is going to point. First is kind of logic. X is greater than 15. Well, where are the numbers getting greater? They're getting greater to the right. So my arrow would point to the right. Another way is to put a test point. So I want to see, is 16 an answer? So if I plug that in for x, I would say 16 is greater than 15. Is that true? Yes. So that means that is one of my answers. So I'm going to draw my arrow pointing to the right. What I mean by a test point now is, let's try 14. Is 14 greater than 15? The answer to that is no. That's a false statement. So therefore, the arrow could not point to the left. So when you're graphing inequalities, two things to consider. One, is the circle open or closed? Can it be equal to that? And then determine which way the arrow is pointing. One thing to be careful of, sometimes people just follow this inequality. That doesn't work if the variable is on the other side. So you have to be very careful with that. So don't get in the habit of following the arrow. A small gift box has the dimensions shown. What is the volume of the gift box? Well, first I need to look. I'm doing volume, so I look right here. I determine this is a rectangular prism. It also tells me right here, volume of rectangular prism. Well, to find the volume of a rectangular prism, volume equals length times width times height. Now I like to do, when I put length, I like to make it a little cursive L. You can just use a regular L. The problem is it looks a lot like the number 1. So if you're not going to use the cursive one, just make a capital L right there, just so you keep it straight. Now we're just going to plug these numbers in. Now, one of the things that often confuses people is which number is the length, the width, and height. Well, in this case, it doesn't really matter because depending upon how I'm looking at the shape would change what people think is the length. So for example, if I'm looking at the shape right now, most people would say this is the length. But if I turn the shape this way, most people would say this is the length. So as long as each number is only used once in this case, it really doesn't matter which number goes into place of what. So volume equals 2 meters multiplied by 1/4 meter multiplied by 3/4 meter. Okay. Now there's two things I'm going to do now. I'm going to multiply each of these numbers, and I'm also going to multiply each of these units. I'm going to do the numbers first. So I'm just going to multiply 2 at a time. So I have 2 multiplied by 1/4. Well, when I'm multiplying fractions, I need to make this into a fraction. So now 2 multiplied by 1 is 2, and 1 multiplied by 4 is 4. So I have 2/4. I could simplify that. I'm just going to go ahead and wait to the end. So now I have 2/4 multiplied by 3/4. So now I go 2 multiplied by 3 is 6. 4 multiplied by 4 is 16. Now, if I'd have simplified ahead of time, my answer would come out in simplest terms now. Now, I just have to simplify it right now. So I look at 6 and I look at 16. Well, they're both even, so I'm going to divide them both by 2. And notice I'm showing that, so my teacher knows where it came from. 6 divided by 2 is 3. 16 divided by 2 is 8. So I got 3/8. Now I have to determine the second thing. The second thing is the units. Well, I multiplied the 2 by the 1/4 by the 3/4. Now I have to multiply meters by meters by meters. Well, that's 3 sets of meters, or meters cubed. So you can write m to the 3rd, or you can write the word cubed. Either one is acceptable. Graph a polygon with vertices, that just means corners, at -4, 4, 2, 4, 2, 0, -4, 0. Find the area of the polygon. So we got -4, 4. Remember from our problem before, we have x, which is side to side, and then y, which is up and down. So -4, 4. 1, 2, 3, 4. 1, 2, 3, 4. So right there. 2, 4. 1, 2. 1, 2, 3, 4. And then 2, 0. 1, 2, and then up or down 0. And then negative 4, 0. 1, 2, 3, 4. Negative 4, 0. And so if you look right here, the polygon I've made is a rectangle. I'm just thickening it so you can see it a little easier on the video. So it says find the area of a polygon. Well, first I'm just going to put rectangle here. You don't have to do that, but I like to identify my shapes because I know a rectangle, the area equals base multiplied by height. Now, one of the things I could do to find the area of this polygon, because they're all whole squares, I could actually just count the squares, would give me the area. But I want to find a much faster way because as these shapes get larger and more complex, I need to use these formulas more and more. So base times height, we go 1, 2, 3, 4, 5, 6 units times 1, 2, 3, 4 units. Okay. And now I'm going to multiply the numbers. So 6 times 4 is 24, and then units multiplied by units is units squared. I can put that 2 there, or I can say square units. So either label is fine. Workers at a company pack 2,610 pieces of fruit in boxes. Each box holds 18 pieces of fruit. How many boxes do they fill? Okay, so I have fruit, and then I'm separating that fruit into equal size pieces, 18 pieces large. So that's division. So I'm going to set this up like a standard algorithm. So we'll go 18 into 2,610. Now, when I'm doing this standard algorithm, I'm going to keep in mind the number 20, and that's called a compatible number. So 18 is a little difficult to multiply by, so it's kind of hard to kind of figure out how many 18s go into something. Very easy to determine how many 20s. So I'm going to use 20 to kind of gauge my guesses here. So 18. So I think how many 20s go into 26? 1. So it just gives me a good starting place to go by. So I go 1. Well, 118 is 18. So this is 16. This is 1. 16 minus 8 is 8. 1 minus 1 is 0. And now I bring down that 1, drop straight down. And now I go 18 and 80. Well, I'm still thinking of that 20. So 4 20s is 80. So I'm going to try 4. 4 times 8 is 32. 4 times 1 is 4. Plus 3 is 7. So 72. And again, I'm going to do some regrouping. 11 minus 2 is 9. And 7 minus 7 is 0. And this number comes straight down. Mark that number off just so I don't get confused. So now, here's where I also use a number that I've used before to kind of help me. So I knew 18 times 4 was 72. So I know 4 isn't going to be enough because I already had 9 left here of 81. So I'm going to try 5 because that's just 1 more there. 5 multiplied by 8 is 40. 5 multiplied by 1 is 5, plus 4 is 9. And so 145. So 145 boxes. And if any of my guesses were wrong, I would just scratch it out, try a slightly larger or smaller number. Find the area of the trapezoid by decomposing the shape into rectangles and triangles. So next year, you're going to learn, and maybe even later this year, you're going to learn a nice formula to kind of shortcut straight into it. But now we're going to use this decomposing. Decomposing is just like in science, it just means breaking apart. So in this case, we're going to break it apart into a rectangle and 2 triangles. Now with this shape, it's kind of handy. Those 2 triangles are identical. So I'm going to do a rectangle and 2 triangles. So now our formula for our rectangle was base times height. So 6 times 4. And I multiply my numbers. So 6 times 4 is 24. And I multiply my units. So inches times inches is inches squared. And now I'm going to do my triangles. Now you could do each of these triangles separate, but I'm going to kind of lump them together. I'm just going to find the area of one triangle and then double it to give me the other triangle. So area of a triangle is 1/2 base times height, because it's half of a rectangle. If I put this triangle with this triangle, it would make a rectangle. So the base is 2. So I'm going to take 1/2 times 2 times my height, which is still 4. And this is inches and inches. Sorry about that. So now 1/2 of 2 is 1, and then 1 multiplied by 4 is 4. But I have 2 of those. So if you think about it, this was 24. This one is 4. So that means this one must also be 4. So I could write 4 inches and 4 inches, or I could say 4 inches times 2, which is 8 inches. But there's one other thing I forgot. Inches times inches. This is inches squared. And therefore, this is also inches squared. So now I just need to combine my 24 inches and my 8 inches. So 24 plus 8 is 32 inches squared. So this was 6th grade Math Blast 9. Thank you.